All right, guys, on the back side of day 5 notes, and in number 3 says, what is the distance between the points AB and 2A, 3B? All right, so because they said the word distance, we're going to say D equals big long square root, parentheses squared, plus parentheses squared, minuses in between. Okay, we're going to go ahead and take the x's first, which is A and 2A, and the y secondly, which is B and 3B. Okay, and now we're going to go ahead and clean it up. So the square root comes down with each step until the end. A minus 2A is negative A, and negative A squared is A squared, right? Anytime you square it, it's got to be positive, all right? And A squared is A squared. Keep the plus sign. B minus 3B is negative 2B. And when you square that, you have to square the negative 2, which becomes a 4, and you have to square the B, which is B squared. Because A squared and B squared, these two terms here are not like, you cannot add them together. And because you can't add them together, you can't take the square root. And so basically you're done here. And there isn't anything you can do mathematically that's correct to go any further. And so we're going to pick our choice, which is choice 4, because that matches. All right. In number 4, we're going to go ahead and find the distance between 8, negative 4 and negative 6, 10. Because they said find the distance, D equals big long square root, parentheses squared, plus parentheses squared, minuses in between. X's always go first in the distance formula, and that's 8 and negative 6. Y's go secondly, which is negative 4 and 10. Okay. We're going to keep the square root because that's not used until the end, but we're going to clean this up in the middle here. 8 minus a negative 6 is really 8 plus 6, which is 14, and 14 squared is 196. Keep the plus sign. Negative 4 minus 10 is negative 14, and negative 14 squared is the same thing as positive 14 squared, which is 196 again. Okay. We're going to go ahead and add them together. 196 and 196 make 392. And because they said simplest radical form, we got to go ahead and simplify it, which seems like a big number to simplify. And you have to find the largest perfect square that goes into 392. And that's going to be 196 because it goes in 2 times. Okay, and you can check it. 196 times 2 is 392 because you literally added 2 of them together. And then the square root of 196 is 14, and the square root of 2 comes down. And there's the length of your line segment in simplest radical form. Okay, number 5. Find the distance. So D equals square root, parentheses squared, plus parentheses squared, minuses in between. Okay, we're going to find the distance between these two coordinates, all right? So X is first, which is negative 2 and negative 14. Y secondly, which is negative 13 and negative 7. Okay, we'll go ahead and clean this up. Negative 2 minus a negative 14 is really negative 2 plus 14, which is 12, and 12 squared is 144. Negative 13 plus 7 is 5. 6, and 6 squared is 36. Okay. If I add them together, 144 and 36 make 180. Because they said simplest radical form, we're going to have to simplify that one. And we can't do the same thing we did in the last one because those are different. So we'll make our list of perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, and that should be a good enough list to find our largest perfect square. We could keep going if we wanted to, but 144 doesn't go into 180 evenly. 180 divided by 121 is not a nice number. 180 divided by 100 doesn't go in. 180 divided by 81 doesn't go in. 180 divided by 64 doesn't go in. 180 divided by 49 does not go in. But 180 divided by 36, 36 is the largest perfect square that goes into 180. It goes in 5 times. And then the square root of 36 is going to turn into the 6 square root of 5. And there's the distance between those 2 points in simplest radical form. Okay. All right, guys, so number 6. It says vector V describes the translation that maps quadrilateral ABCD to quadrilateral A prime, B prime, C prime, D prime, shown to the right. They want to know what the magnitude of V is. And V is the vector, and magnitude is the length or the size of that vector. And so because it's length or size, okay, that tells me to do distance. So I have to do the distance between the 2 points that vector connects, which is D and D prime. So before I start, I'm going to write down the coordinates of D, which is at -9, -1. And I'm going to write down the coordinates of D prime, which is -7, +2. And now I'm going to go ahead and find the length or the distance between those 2 points that the vector connects. All right, so structure of my formula first. And then I'm just going to go ahead and plug in my x's, which is -9 and -7. And then my y's, which is -1 and 2. Okay. Here in the first one, -9 minus the -7 is really -9 plus 7, which is -2. And -2 squared is +4. Okay. In this last one, -1 minus 2 is -3, and -3 squared is +9. Add them together, 4 plus 9 is 13, and 13 cannot be reduced. The only perfect square that goes into 13, guys, is 1, and 1 doesn't count when we're simplifying radicals because it doesn't help. It keeps it exactly the same. So that is the length of vector V. All right, one last question here, guys, in number 7. Oh, it's got 2 parts, but that's okay. All right, number 7, guys, says that the vertices of triangle P, Q, and R are those, and they're saying using the distance formula, show that triangle PQR is isosceles. And we haven't seen isosceles triangles in a while, but hopefully you guys remember they have 2 congruent sides, or 2 sides with the same length. And so because they have the same length, that means the distance between them, right, between the points will be equal. All right, so basically you have a triangle, P, Q, and R, and they want me to show that 2 of these sides are equal. Now, problem is, I don't know which 2 sides it is. It could be PQ and QR, it could be QR and PR, it could be PR and PQ. Well, we don't know. So we're going to go ahead and set up 3 distances to find the distance of each side. And therefore, hopefully 2 of them come out to be the same. And therefore, we just showed that it's isosceles because we showed that 2 sides were equal. So we're going to go ahead and set up, and we're going to have to make sure we leave some space here. So we're going to do distance of PQ first. And we're going to go ahead and grab, the x coordinates from P and Q. Okay. So P's is 1 and 7. And Q, our Y's are -1 and 1. All right, so we're going to go ahead and clean this up. And I'm just going to go straight across here, I think, just so I have room to do 2 more sides here. All right, so 1 minus 7 here, guys, is -6, and -6 squared is 36. -1 minus 1 is -2, and -2 squared is 4. And this gives me the square root of 40. Now, I would simplify this radical if they asked me to, like in the last couple questions, but they don't, so I'm going to leave it. In fact, what I'm going to do is I'm going to take PQ in my picture here and put the square root of 40 on that side. So I remember that that is the length of that side. All right, I'm going to do my next one. So now that I did PQ, I'm going to do QR. And I'm going to find the length of that side to see, and I'm hoping it comes out to be the square root of 40, because if it does, I'm finished. All right, so I'm going to go ahead and take Q and R's x coordinates, which is 7 and 3, and their y coordinates, which are 1 and 3. And we're going to do the same thing. 7 minus 3 is 4, and 4 squared is 16. And 1 minus 3 is -2, and -2 squared is 4. And so this comes out to be the square root of 20. And that square root of 20, I'm going to put on the side called QR. That's the length of that side. So did I show that this triangle is isosceles yet? No, I have not. However, I'm hoping that my third side either comes out to be the square root of 40 or the square root of 20, and that way I'll have two equal sides. Okay? So my last distance is the side PR. And P and R, let's see, their x-coordinates are 1 and 3. And their y-coordinates are negative 1 and 3. One minus 3 is negative 2, and negative 2 squared is 4. And 1 minus 3 is negative 4, and negative 4 squared is 16. And when we add them together, we get the square root of 20. And so that's good news, because now I have QR and PR being the same length, and I just showed you that this triangle is isosceles. Okay, so just to show and write a little bit, which is what we would normally have to do, we're going to say that QR is congruent to PR because their distances are the same. Okay, and we're going to also say that if a triangle has two equal sides, it is isosceles. All right, so we just proved to ourselves that this triangle has two equal sides by finding the distance, okay, and making sure that they come out to be the same. All right, guys, part B. It says, show that triangle PQR is a right triangle using the Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. And when we plug in our three sides of the triangle, we have to make sure that C gets replaced with the largest side. And of our three sides, square root of 40 is the largest. So we're going to make sure that square root of 40 goes in for C, but don't forget to square it. Okay, we're going to take the square root of 20 and put that in for A. Don't forget to square it. And we're going to take the square root of 20, put it in for B, but again, don't forget to square it. Cool thing about this one is that the square root of 20 squared is actually just 20. Square root of 20 squared is again 20, and the square root of 40 squared is 40. And over here, 20 plus 20 is 40, and 40 equals 40. And anytime three sides put into the Pythagorean theorem, left side equals right side, we just showed that it's a right triangle, okay? And so because our sides work in the Pythagorean theorem, okay, this is definitely 100% a right triangle, okay? So we're just going to say sides work in Pythagorean theorem. So triangle, I guess we could say triangle PQR is a right triangle. All right, and that's it. All right, guys, I'll see you guys on day 6.